All right, we've got position, displacement, velocity. The fourth vector is acceleration, and this is by far the most confusing for students, okay? One of the reasons is because most people think that accelerating is just speeding up. It's not just speeding up. So this picture over here shows what acceleration looks like, right? So if these pictures of this skateboarder going downhill were taken like every frame of a video, then we can see that the skateboarder is traveling more distance each moment in time, right? Their change in position is increasing. So they would clearly be going faster or speeding up. That would be if they're moving downhill. We would say they're speeding up, they're accelerating. But it's also possible that we could look at this picture backwards. Maybe the skateboarder is actually traveling left. The skateboarder had a bunch of speed and then hit this hill and then started going uphill. And if the skateboarder was going uphill, they would actually be slowing down. And yet, in physics, we would still say that they are accelerating, because accelerating is any change in velocity. That's our formal definition, a change in velocity over time. In other words, the rate of velocity change, okay? So you could be slowing down and that would still be considered accelerating. And in a moment, I'm actually going to tell you about a third way that you can accelerate. But for now, in equation form, we use the variable a, right? So a sub x would be horizontal acceleration, which is a change in horizontal velocity over time, or a sub y is vertical acceleration, a change in vertical velocity over time. And acceleration measurements sound very weird because time shows up twice. Time shows up here in the denominator, but then time is also embedded in velocity, right? Because velocity is the rate of change of your position. So this is how accelerations sound like. Negative 9.8 meters per second squared, which is the same as like meters per second, or positive 4.2 kilometers per hour per second. That means that every second, the velocity changes by positive 4.2 kilometers per hour, or 1.6 meters per second downward, right? We've got the magnitude and the direction in each one of these. So there's two rates of change in an acceleration vector. And now, even harder to wrap your brain around is what a positive and a negative value means for acceleration. So a positive value means for acceleration that you're being pushed in the positive direction. And if you're familiar with the idea of net force, it specifically means that you have a net force in the positive direction. But it doesn't mean that you're necessarily moving in that direction, just that your net force is in that direction. And then conversely, if you have a negative acceleration, it means that you're being pushed in the negative direction. In other words, that you have a net force in the negative direction, but you don't necessarily have to be moving in that direction presently in order to be accelerating in that direction. Okay, and I'm going to clarify that in a moment. So position, displacement, velocity, acceleration. This was what I was mentioning earlier, that acceleration is not just speeding up. So if acceleration is any change in velocity, then there's actually three ways to accelerate. I mentioned the first two already. The first is speeding up because you're increasing your speed. This we would call accelerating forwards, right? Like, in other words, you're being pushed in the direction that you're already going. But you could also slow down and still be considered accelerating, at least in physics terms. And the reason why you're accelerating is because you're decreasing your speed. So that counts as like a change in velocity. And if you're slowing down, you're always accelerating backwards, right? Accelerating backwards. So maybe you're moving forwards, but you're actually being pushed back while you're moving forwards. There is a third way to accelerate, however, and that would be if you're turning. And the reason is because if you're turning, you might not be changing your speed, but you are definitely changing your direction. And that would count as accelerating, right? Because any change in velocity is an acceleration. And so turning would be considered accelerating sideways. You'd have to be pushed to the side in order to make a turn. So three ways to accelerate. All right, so let's review the differences between the velocity and the acceleration vectors. And we're going to look at 6 situations here, okay? So see if you can identify the direction of the velocity and the acceleration vectors. Situation number one, we have a car that is moving to the right, and these dots are trying to show the position of the car each moment in time, like at even time intervals. And so the dots are getting farther and farther apart, so the car must be speeding up as it goes to the right. Well, starting here, what's the velocity vector? Well, velocity is always the direction that you're moving. So the velocity would be to the right. And then acceleration is always in the direction that you're being pushed or that your net force is in. And so in order for you to speed up to the right, you would have to be pushed to the right by a net force. What if, however, in situation two, you're moving to the right, but you're slowing down as you move to the right? You can see that the dots are getting closer and closer together. Well, since you're still traveling to the right, your velocity is to the right. But as you travel to the right, something must be slowing you down. And specifically, something must be pushing you to the left. Therefore, you're accelerating backwards, and your acceleration is to the left. Situation three, what if you're not speeding up or slowing down? You're just moving at constant speed while traveling to the right. Well, again, your velocity would be to the right. But in this case, since you're not speeding up or slowing down or turning, and since you can move at constant speed by your own inertia without a net force, then you're actually not accelerating at all, and you would have no acceleration vector. All right, so let's consider three situations now where you're traveling in the opposite direction. So situation four is where you're traveling to the left, but you're speeding up while moving to the left, right? You can see the dots are getting spaced out more and more and more. Well, your velocity is going to be to the left because you're moving to the left. But then as you speed up while moving to the left, you must be experiencing a net force to the left. Something must be pushing you to the left to make you go faster. Therefore, your acceleration vector must be to the left as well. That's why you speed up, because you're accelerating in the direction that you're moving. Situation five is where you're moving to the left again, but you're slowing down. So your velocity is to the left because you're moving to the left. But as you slow down, you must be pushed backwards in order to slow down, right? So you must be accelerating in reverse. That is why your acceleration vector would be to the right. And then finally, situation number six, you are traveling at constant speed to the left. And since you're moving to the left, your velocity is to the left. But since you're neither speeding up nor slowing down nor turning, you don't need a net force in order to do this. And so there is no acceleration vector at all in that situation.